Although fire hose is the basic equipment used in a fire scream, hose appliances are important for controlling the flow and discharge of the water. In this program on hose appliances, you will see many of the most common types of hose appliances and how to select the correct one for various types of fire situations. The learning objectives are to define fire hose appliances and list different types of appliances, to show types of valves and how each type works, to present types of valve devices and when to use each type, to describe fittings and intake devices, and to demonstrate how to clean and maintain hose appliances. Hose appliances are defined as hardware, excluding nozzles, that connects to fire hose to convey or control water. Fire hose appliances have water flowing through them, as opposed to fire hose tools, which do not flow water. These appliances include a variety of valves and valve devices, fittings, intake devices, and portable monitors. You should understand all fire hose appliances your department carries and how to use each one. NFPA 1965 sets minimum performance and testing standards for new fire hose appliances. The standard requires new hose appliances to be permanently marked with the name of the manufacturer, the product or model, and the maximum operating pressure. All fire hose appliances must have a maximum operating pressure of at least 200 pounds per square inch or 1,380 kilopascals. The fire hose appliance and the hose it's attached to must be carefully matched. The fire hose appliance should have a higher maximum operating pressure than the hose. There are many types of valves used to control the flow of water from the hydrant or pump to the hose line. A valve is a device that contains an internal component that moves within the water passage to regulate the amount of flow. There are 4 basic types of valves, and each is named for the type of internal component that it contains. They are gate, ball, butterfly, and clapper. Gate valves have a component that moves into the water passageway when a crank handle is turned. Gate valves are well suited for use on a hydrant or a pump discharge orifice.
Water to you.
It is difficult to open them quickly, but this is an advantage because it reduces the chance of water hammer. Ball valves are the most commonly used valve in the fire service. They have a ball-shaped internal component that has a hole in the center. When the ball is positioned so that the hole is aligned to the waterway, water can flow. When the handle is turned, the ball rotates and the waterway is blocked, stopping the flow. Butterfly valves have a disc that pivots within the waterway. When the disc is parallel to the waterway, water flows. When you move the handle, it turns the disc across the waterway, closing it off. Butterfly valves are often used on large pumper intake openings. A clapper valve is a hinged disc that swings open like a door to control the flow of water. The clapper valve in a Siamese appliance directs the flow of water and prevents its discharge from an unused connection. Valve devices enable you to make the best use of hose lines in any situation on the fire ground. Many times, a simple valve, hose, and nozzle setup is not enough to accomplish the objective. For example, if you have a very long hose lay, you may need to boost the pressure to overcome friction loss. Or you may need to increase or decrease the number of hose lines on the fire ground without interrupting the water flow. Valve devices make this possible. Valve devices include hydrant valves, Siameses, Ys, water thieves, and manifolds. A variety of hydrant valves are used in supply line operations. Hydrant valves connect a supply line to a hydrant so the line can be charged immediately, and a supply engine can connect to the line later. This allows you to boost the pressure without any interruption of flow. When you are pumping to fires that demand an ever-increasing volume of water as the fire grows, this capability is especially important. A typical scenario for using a hydrant valve is this. A pumper arrives at the hydrant and lays a forward or straight lay. The pumper stays at the fire scene to act as a source for tools and equipment while the supply line is charged. When a second pumper arrives, it is placed at the hydrant to boost the supply hose pressure. A hydrant valve diverts the hydrant water that is flowing into the supply hose and reroutes it into the second pumper, where the pressure is boosted. Now, this higher pressure water is fed back into the supply hose, significantly increasing the water flow rate. One way to reduce friction loss is to lay two parallel lines and then bring them together closer to the fire. To do this, you would use a Siamese appliance. Attach the Siamese inlets to the smaller supply hoses and then attach a larger hose to the outlet. Most Siamese appliances have clapper valves that prevent backflow if the two supply lines have unequal pressure. When you need to supply water directly to two attack hoses with a single supply line, a Y is one of the best appliances to use. A gated Y has manually operated valves that allow separate control of the water to each line. A reducing Y, commonly called a leader line Y, provides water for two attack lines of smaller diameter than the supply hose. The water thief is a variation of the gated Y. A standard water thief is attached to a 2.5-inch or 65 millimeter or larger hose line. It has a quarter-turn valve on the 2.5-inch or 65 millimeter outlet and on each of the 1.5-inch or 38 millimeter threaded outlets. This allows you various options. You can use either a 2.5-inch or 65 millimeter hose or up to two 1.5-inch or 38 millimeter hose lines. A manifold is a device that receives a supply of water and distributes it through valves to a number of hoses. It is especially useful when you have a fireground situation where you have limited access to the buildings, such as large apartment complexes or shopping malls. Using a manifold with large diameter hose cuts down on the amount of time needed to lay multiple hose lines, and it usually allows you to operate at lower pump pressure. Fittings and intake devices help complete the system for delivering water through hose. Fittings help connect hoses of different sizes and thread types. Adapters are fittings that connect hose couplings with the same diameter but with different threads. Double female and double male adapters are most common. Adapters to connect sexless or stores couplings to threaded hydrant outlets are increasingly common. Reducers are a type of fitting to connect a smaller hose line to a larger hose line. Elbows are fittings that change the direction of flow. Intake devices include strainers attached to the drafting end of a hard suction hose drafting from a static water source. Some departments use ropes or floating strainers to keep the strainer off the bottom of ponds and lakes. However, you can allow the strainer to rest on the bottom when drafting from a swimming pool or other water source with a clean, smooth bottom surface. To get the maximum effectiveness and service life from all hose appliances, you must keep them clean and well maintained. There are arguments for carrying appliances with valves open and with valves closed to protect them from accumulating dirt and debris. Make sure you follow your department's SOPs. Make connections hand-tight to avoid flattening the gaskets. If you must use a spanner wrench to tighten a leaking connection, tighten it only enough to stop the leak. Thoroughly inspect an appliance after each use, and inspect all appliances on a scheduled basis. Before cold weather season, lubricate the threads to prevent fittings from freezing when coupled. Use non-greasy lubricants such as silicone or graphite on moving parts to avoid damage to the gaskets or other rubber pieces. Non-greasy lubricants are important because they won't accumulate dirt and grime over time. Replace worn gaskets as needed and carry spare gaskets on the apparatus. Wipe hardened aluminum alloy devices clean with a soft cloth and non-abrasive cleaner. Aluminum devices should not be polished. When necessary, repaint the outsides of appliances to prevent rust and corrosion. Be careful to not paint the threads. Fire hose appliances offer you many options for controlling the flow and discharge of water. In this program on hose appliances, we have shown the basics about fire hose appliances, the most common types of valves and how each type works, several types of valve devices and when to use each type, types of fittings and intake devices, and how to clean and maintain hose appliances. When you are first setting up your supply and attack lines, you often don't know how the fire's going to go. It may be a slam dunk, and you're back in the station in an hour or so. Or it may get really ugly really quick. By taking a few extra seconds to select and use the correct hose appliances for a worst-case scenario, you save yourself the agony of figuring out what you're going to do if the situation turns out to be just that.